As engineers, we get to meet and talk to so many of you, our customers and partners. It's been great hearing in the last few days all the exciting things you're doing with the platform now, and even more that's coming. So for 3 days now, you've heard all about the rich software platform. Some of you have been working with these devices for years now. You've watched and helped us grow it to where it is today. Underneath all of the software, everything runs on hardware. This session, finally, we can look at the new devices coming, new architectures to enable them, and just exciting software to build on it in the future. So, a popular question: why does Microsoft, the software company, care about hardware? Mobile devices, it's not like shipping a copy of Office. It doesn't come on a box that you install a CD. Hardware is a crucial part of the device experience for the user. And we make a big investment to help our OEMs and partners ship the best possible hardware. We can ship software. Users have a great experience. Important thing, though, is that we do not ship hardware. We're out to help our partners ship better hardware. At the same time, we're not trying to compete with them. We're a software company, and that's our plan for this space. In the mobile devices group, there are two key devices for us: smartphones and pocket PCs. We look at all kinds of other things, but those are the devices you're most familiar with and most of what we'll be talking about. Besides the devices, it's a software platform, but it's also a hardware platform. We support a number of peripherals, from cameras, hard disks, little remote controls. And it's also to look at the hardware architectures. What goes on underneath? By getting good analysis of this, we can get more optimized software to run on top of it. Now, once again, we do not ship hardware. It's very important to understand that. And you'll see some devices that we've built internally. But we do this to help our partners. And these are just prototypes and concept designs. They're not reference designs. They're not intended to be shipping hardware. By building these designs, we can really focus on the architecture. There are some key metrics for mobile device hardware: power, size, weight, and cost. Very important. People want devices that the battery lasts forever. They want it to be small. They want it to be cheap. These things conflict, but we get there. And to do it, we don't build desktop-sized development boards. We actually build form factor devices. So same kind of plastic, magnesium housing that you might find on a store shelf, but just in a prototype fashion. And on these designs, we work very closely with our OEM partners and ODM partners and silicon vendors. The OEMs to help improve their designs, and with silicon vendors to make sure that 3 years, 5 years, even 8 years down the road, the right chips are out there to make the best devices. Now, as a model for understanding ways to improve the hardware, I like to think of all the shipping products, put them inside a big box. And so the sides of the box are device metrics. We have form factor on one side, feature rich on another, low cost, high performance. And the device is going to sit somewhere in the box. Our job as part of the hardware team is to make the box as big as possible. We want tiny devices running Windows Mobile. We want the highest performance, feature-rich devices. We want low-cost devices. Now, it isn't going to be the same device that's smallest and lowest cost that has the most features. Trade-offs are key part of any engineering design. It's trade-offs. But by pushing hard in one of these areas, it affects other areas too. Any work that we do on a small form factor design, it may not make the most feature-rich design tiny, but it's going to help. And when we're evaluating new designs, we try to push by at least 20% in one of these areas. And you'll see that with some of the prototypes I'm about to show you. Pushing into new architectures, there's risk involved. Software development, you write your code, you compile it, it has some bugs, you fix them, you compile it, it has some bugs, you fix them, you compile it, you release it, has some bugs. But hardware, it's a little bit different. You do the design, you send it off for manufacturing, a month or two, and some tens of thousands of dollars later, you get back a piece of hardware. So in a product development cycle, mistakes can be devastating to a schedule. It could make the difference shipping or not shipping a device. On the research side, if we want to explore, let's say, a new audio architecture, we can do that. If it doesn't work, well, it doesn't work. And we may have saved one of our OEMs or another partner that expensive learning. So now, looking at architecture, it's easy to say, well, why don't we just use desktop-sized development boards? Why do we do form factor designs if we're not trying to ship these devices? Well, hardware is cool. It's also just a great way to prove what's possible. One thing to come up and tell you, well, I'm going to make you a phone this big. It's going to have this stuff on the screen. But to actually be able to put that in your hand to show you, let you feel what the device could be like next year, 2 years, 3 years from now, the only way to do that is by building the hardware. While we don't ship hardware, we do ship hardware specifications to our OEMs to help them figure out what the device should look like, how big it could be, what kind of battery life. Without building the devices, it's hard to be credible there. We learn a lot building these devices. Our partners learn a lot building their devices. Our partners learn from us building devices too. With all these specifications, we want to have the smallest, best, most power-efficient device out there, but the specification has to be achievable. If an OEM is wasting time developing for something that's just not realistic, well, we failed there. And by building the devices ourselves, we can help make sure that they're chasing a good goal. Now, looking at hardware form factors, again, there are two types of devices that we look at. And I know most of you are very familiar with these, smartphone and Pocket PC. We still get asked, with Pocket PC Phone Edition and smartphone, which one's better? Why don't you pick one? Pick one device. And why are you going to keep supporting both? Yes, absolutely. One device is better, but it's better for you or you. It's not that one device is better for everyone. And so the important difference is in the navigation. Smartphone, no touchscreen. Pocket PC, touchscreen. And that distinction is going to stay, but you'll see some of the other distinctions you might have had based on what it looks like, what it feels like, that can start to change going forward. A big focus for the second edition software is enabling hardware innovation for our partners. One way on smartphone is with new screen sizes. Current smartphone screens are all around 2.0 inches. And now, from 1.8 on the small side, all the way up to 2.9 inches. And this picture is to scale what a smartphone screen would look like with a current screen in the middle, small on the left, big screen on the right. Now, you might ask, well, 2.9 inches, that's huge. It's clunky. Why would I want a smartphone that big? The idea of this hardware innovation isn't just to see larger and smaller versions of what you're used to seeing already. This is actually enabling entirely new form factors. And regarding the pixels, we also have new resolutions. Many of you went to talks for developing resolution-aware applications for high DPI and saw slides of, OK, this is how much more information you can fit on the screen, but we have hardware. So not sure how well you can see it, but on the left is a quarter VGA smartphone. So it's a real phone. You could put it in your pocket and carry it. This is actually an internal design that we did within our group. And it has a quarter VGA LCD. The difference in clarity is amazing. The screen is breathtaking for text quality, the brightness, the contrast of the new screen technologies. And I'm not sure. Someone in the back, can you see that? OK, great. And just on text and also anywhere there's graphics. It's just a great experience working on the new screens. On Pocket PC, we've also enabled different orientations. Now, portrait devices are great for list-based navigation, some other tasks, a lot of tasks, really. But landscape can be really wonderful for doing email, messaging, communications, using your camera. There are reasons for each. And we don't force an OEM to choose that, oh, I'm going to ship a device that's portrait, or I'm going to ship a device that's landscape. We actually have dynamic rotation. Now, for messaging, the device on the right is a portrait mode device with a keyboard attached to the bottom. I actually have one that you'll see in just a minute. It's unfortunate, that if you have a portrait device and you put a keyboard on it, it's going to be long. It's going to be a longer shape. There's no way around it. It has to fit. But on the left, there's a portrait device that has a slide-out keyboard, except it slides out the other way. So you can have a device that's used for all the ways that you're used to using it now, and then pull out the keyboard, flip it around, optimize messaging device. These are the kinds of things that are coming. Also have square screens. Again, at the lengths of the portrait screen, you could have a flip-out keyboard sideways. But for messaging, there's just some great possibilities for clamshell form factors that the square screen makes for just a beautiful and well-balanced, comfortable device. And more screen sizes, all the way down to 2.7 on the small side and 4.1 on the big side. Current screens, all around 3.5 inches. Now, you might ask, why don't we just 2.7? It's so tiny. Why would I want that? I can't see anything. 4.1, it's big device. But they're different devices than you might be used to conceiving of. On the left is a very tiny landscape messaging-based device. It's so small it actually has a phone keypad on the outside of it. You can put it in your pocket and carry it like a phone, flip it open, have Pocket PC messaging functionality, and everything else that comes with it. In the middle, square screen Pocket PC, slide out keyboard. On the right, a large screen device, camera. Large screens are great for media applications, watching video, taking pictures, just a lot of new possibilities. The idea here, again, is it's not to make just bigger and smaller devices. And with new sizes, there's also new resolutions for Pocket PC. And more likely, some of you have seen Pocket PCs in high resolution. But this is also, again, using one of our internal prototypes. The text clarity on VGA Pocket PC is just, it's amazing. It's, when we first started looking at VGA screens, I'm an electrical engineer, so I'm just, oh, it's going to be so much power. It's, it's not that much better. I was a total naysayer, but the first time we built the prototype, turned on the screen, it's just totally sold. If you haven't seen one of the new high-resolution devices, you should definitely check it out. Now, with all the new screen sizes, all the new resolutions, you start to almost see overlap between smartphone and Pocket PC. These devices here, that one on the left, clearly a Pocket PC with the keyboard, but it has some phone functionality in a phone-type form factor as well. The one on the right, phone, looks like a phone. How many people think that's a smartphone? Take a guess. How many people say Pocket PC? Well, clever as you all are, it's a Pocket PC phone edition, but with a phone keypad in a phone form factor. Now, smartphone has to have a phone keypad. It's a phone first. Pocket PC, it doesn't have to have a phone keypad, but there's nothing in the spec that says it can't. So in some markets, Pocket PC, just the advantages for text entry and other areas really make it preferable for phones. This kind of form factor with the new smaller screens makes that possible. Now, if you look at all the devices out there on the market, let's just it's kind of a big jumbled mess, right? Everything from pagers, remote controls, phones, PDAs, laptops, desktops, your television. It's really tough. You're going from one device to another. With all the new screen sizes, new resolutions, new ideas for form factors, you can have a smooth and consistent experience all the way from small remote controls up to laptop and desktop computers. Several kinds of phones, different PDAs, gaming-targeted devices, devices more focused on clever industrial design, hip, fun devices, multiple screens, video, anything you want, but all with that same consistent user experience. Now, in making new devices, it's important to keep in mind what these devices are going to be used for. So we have critical design criteria for any device that we look at building and any device that we're evaluating on the market. First thing are size and battery life goals. Smartphone, it's a phone. It's competing with phones. It has to last a long time in your pocket. It has to talk for a long time when you're talking. Pocket PC, again, has to have, in the phone edition, great standby and talk time, also the PDA usage time. But talk time and standby time numbers are great for evaluating feature phones, and that's what you do. You talk on it or you stand by on it. That's it. With smartphones, Pocket PCs, more questions come to mind. How long can I play music on my phone? What if I want to watch TV, watch some movies on the airplane on my Pocket PC? So we've started to look more at scenario-based requirements, looking at how the user uses the device and what kind of battery life they'll expect in their own daily use. Do extensive modeling, take measured data, have data collection apps running while people are using their devices, go back, reevaluate, and can help try to figure out how many days of use a user might get from a device in various profiles. It isn't necessarily something that could be put on a box, but it helps us and our OEMs understand much better the important issues and focus our design efforts in the right places. Now, hardware is a platform too. We have a core platform, but it can be extended in a number of ways. In common peripherals that you'll see, cameras, hard drives, secondary displays, pendant, remote control kind of devices. Again, Microsoft isn't shipping these devices. Our OEMs, partners, IHVs, other people are shipping these devices, but we do a lot of work to make sure that these devices can work well with our platforms. In the current software, camera is mostly left up to the OEM. But in the future, we're providing a standard camera interface. So any of you can go out and write a camera application. Someone will put it on their Pocket PC with a camera, on their smartphone with a camera. It'll work. They can take pictures. No problem. And besides the software side, we look really trying to make sure there's a good user experience. So we have recommended minimum camera specifications for resolutions, frame rates, in timelines going forward for the next few years. And we also enable hardware imaging pipelines. Imaging is a really exciting place for hardware architecture right now. All kinds of clever ways to have camera data go straight to the screen without taking up time on your CPU, power efficient, automatic recording, encoding, compression. The best part is, all abstracted for you. Don't have to worry about it. It's just going to happen. Your app will work whether it's on a device with all the hardware acceleration available or a device where the CPU is running around like crazy trying to get it all done. Might work faster on one, but it'll work either way. Now, hard drives are something that could be implemented today. They're getting smaller, they're getting faster, they're getting cheaper. Why not put one in a mobile device? Well, you can, no problem. It's just another file system. We've had installable file system support for a long time, just like having a storage card. So as developers, it's important to look at some of the performance and power considerations of any file system. Just like on the flash file system versus the RAM file system. It's slower. You can't sit there and thrash files all the time. Now, hard drives are another issues. And while it can be done today, there's definitely room for optimization. And we're looking closely at this and trying to make the most power-efficient solution possible. Secondary displays are great. On the outside of your phone, phone's closed, you can look at the time, the date, see who's calling. But from a software standpoint, it's an OEM area. We encourage them to do it. We have extensibility specifications that we provide to our OEMs. So we've done all the user research for various sizes, resolutions, how many buttons, repurposing other buttons, different icons to put on them. So users will have a consistent experience wherever possible, but it's definitely an area for OEMs and partners to differentiate themselves. And also in remote control devices. You could have maybe a key fob to data vault or a media remote to control the radio station, what track you're listening to, show it to you on a screen. It's all possible. And we've even gone to build a new standard bus for these style devices that hang off of the headset and provide specifications and connectors to OEMs and partners to build these things. Now, to get into any of these new form factors, it's really important to focus on the architecture underneath. Now, main areas for consideration: memory, power, 3D support, multimedia. And these are some big areas for advancement. Now, processors are too. They aren't on here, but it's a different category. There's a different type of involvement. Processors, there are several on the market. There's not that much variation in what's available as far as new features. Some are better performance, some are better power, but they all have pretty similar features. Memory, though, varies greatly device to device. There are different types of memory. There are different ways to connect the memory. And each has its advantages. Some are cheaper, some are faster, some take less power when they're running, some take less power when they're turned off. Software developers, the apps are going to run well no matter what. That's an important thing to consider, is that you won't know what the underlying file system is. You can't assume that you're running on top of, necessarily assume that you'll always be running on a RAM file system where you can thrash files all day. And there are some sessions on working with persistent store that are very important, important information for how to deal with this. Now, the two types of memory that are in devices are flash and RAM. The big difference between the two memories, so flash, you can pull out the battery, all your data's there. RAM, if you pull out the battery, all your data goes away. This is why if you take a smartphone and leave it in a desk for a week, a month, of course you're using it, but as long as it sits and eventually the battery dies, all your data is still there, no problem. Pocket PC, I'm sure many of you have had that experience of letting the device sit, the battery dies, your data's gone. That's because Pocket PC keeps its data in RAM, smartphone as the user data in flash. Now, RAM, though, is very fast. Performance is great out of RAM, but it also takes power. Flash is much slower, and the speed difference between RAM and flash could be from 10 to 1,000x, depending on the type of operation. Really, 3 orders of magnitude. It's huge. And then there are different types of flash out there to confuse it more. NAND, NOR. There's flash that you can read directly from, flash that you have to page from. But important thing when looking at device specifications, when you talk about how much memory it has, how much flash, and how much RAM, getting a device with a ton of RAM, putting a lot of RAM in a device is just not a great idea. It's going to impact your battery life, whether you're using it or not. Flash, on the other hand, is great. You can have as much as you want, all the user storage you want. No problem. Put a gigabyte in there. Great. And it won't make a ding in your battery life. Now, talk about that smartphone and Pocket PC have 2 different architectures for code and data storage. In both cases, the code is stored in flash. Now, smartphone, one of those cases, code stored in flash. there are two ways to do this. You can either XIP, which stands for execute in place from NOR flash, or you can demand page from NAND flash. We talked about that flashes have different access models. NOR flash is random access. You can just set a pointer to it, start running code, no problem. NAND flash is more like a disk. You have to page code into some other type of memory, and then you can execute from it. It's only sequential read within a page. So once the code is running, it's actually running out of RAM in that case. Now, again, the PIM storage and the file system are in flash, and the RAM is only used for temporary storage. Heap, stack, application RAM, just no object store in RAM. In Pocket PC, again, the file system's in RAM, so the data is lost if the power is removed. And also, if a device has a ton of RAM to provide user storage, that's going to make a significant impact in the battery life. There are performance trade-offs with all of these solutions. And the demand paging solution is your code will run blazingly fast once it's loaded, but you'll see some delay on application launch and execution. XIP, your code will launch very quickly, not be quite as fast when it's running. Again, just like everything else, it's a varied platform. All the apps have to run well on all the devices. It's just going to be an issue that some devices will be more performant for some applications. Other devices will be more performant for other applications. But having a good understanding of the options, some of the situations that your app might be running in, can help you to have an app, to make the right choices, make the right compromises and trade-offs in your software applications to have a good experience on as many devices as possible. Now, power is another great area for us to work on. It works differently for smartphone and Pocket PC. I don't know how many of you went to Scott's talk yesterday about developing code for more power efficient. If not, you should definitely try to catch that on the DVD. There are some good things you can do in software to improve battery life. This is a plot of power versus time on a smartphone device. The device is just, it's off. It's sitting there on the desk, doing nothing. It's registered on the network, waiting for a call. Now, power is on the y-axis, going up and down on the graph. Time is on the x-axis. And that curve there, the area under that curve, that's energy. Energy that your device is using. Your battery life is inversely proportional to the area under that curve. Fundamental math works no problem. Easy to understand. Now, the really interesting part of this graph is how little software is actually running. Look, there's kind of a baseline. There's an idle baseline that is going to be a function of the hardware. This is an area for the OEMs. Then, looking out in time, anytime there's a spike there, software is running. It's doing something. That's our problem, collectively. We'll do as much work as we can to reduce the CPU usage in the operating system. You should do the same for your applications. Now, the two big spikes, though, that's not even Windows CE. That's not the OS. That's not anyone's applications. That's actually the GSM phone. The overhead for a smartphone compared to just a radio module with no screen, that's those two little spikes in the middle. Our CPU utilization is about 0.2% when sitting there idle. And then it immediately drops to this low power idle state, ready to wake up on any interrupt or any need and keep going. Pocket PC is a little different. It's not optimized in the same way that smartphone is. But that's not an excuse to be careless when you're doing your application development. There is still a difference when it's running or not. And looking at this graph, all that area with the activity on the left, that's Pocket PC sitting there on the Today screen. It has a much higher baseline. Your backlight is probably on. It's a larger screen, different kinds of processors. And there's a lot more activity, more stuff going on in the system. Going forward, we'll start getting more towards the smartphone model. And the best software practices that you can do for developing smartphone applications to be power efficient, those are going to help you on Pocket PC too. To look a little more at that, now on smartphone, every boot is a cold boot. It's just like if you took the battery out, put it back in, conveniently all your data is still there because of the flash file system, but the OS never suspends. We don't call OEM power off, close all the network connections every time you close your flip. And the LCD, again, always on in a candy bar phone. I say usually because a flip style phone would actually turn off the screen. But from a software standpoint, the drivers don't know that the screen's turned off, or they know, but they can still write to the screen, update the time. Nothing's broken because the phone is closed. And again, and while Pocket PC doesn't work that way today, when you push the power button, it's effectively off. There's nothing scheduled. Alarms can wake it up. But it's not going to take any interrupt and start running the next thread. You can still do the same thing in software, because in future versions, it's a good possibility to move to that power model. So much better for the user. And the thing that makes it work is that the system drops all the way down to the idle state as much as possible. I got between taps on the screen, between key presses, the processor gets into the lowest power state, the memory gets into the lowest power state. The device is pretty much ready to go at a moment's notice, but just that, just standing there sitting. But it's ready. Anything that happens, it can start right up, 100 microseconds, no time at all almost. Now, looking at that graph, its time going across is the software that's running. Again, I just can't stress enough how important it is to not run any more code than you have to. So there's a great talk on that you should catch on the DVD, but otherwise, big things, eliminate periodic polling, take interrupts, don't wake up every half second just to wake up every half second and figure out what to do. If you have animations, limit the time that they're running. If you look at things like Bubblets, you'll see it has an animation and you let it sit long enough, it stops. That's great, because if you don't want to have someone who starts your app, puts their smartphone down on the table, and kills their battery because there's something spinning around the screen that they weren't even watching. It's great to have animation and show that to the user, but they shouldn't have to pay for it if they're not using it. And also, if your app's in the background, there's no reason to animate it at all. And again, timers, it's another instance of polling. Don't wake up any more than you have to. Besides being power efficient, we want performance too. And graphics are a really exciting area for this. Especially with the new resolutions, faster processors, accelerators, you're going to see just some amazing games coming out and other applications. We have Direct3D Mobile. It's a whole talk on that you can catch on the DVD. Various types of hardware accelerators and just performance that you haven't seen on devices to date. The difference between hardware and software acceleration it's easily a factor of 10. You can go from the realm of 100,000 polygons per second, some form of shading and clipping and filling, to more towards 1 million polygons a second. We're talking about the performance that you might see on early game consoles, PlayStation 1 performance, but on your Pocket PC or even your smartphone. It's amazing. And from a software standpoint, we abstract it all. So your app will run whether the device just has software emulation or it has the best pixel shaders out there. Doesn't matter. Your app's going to run. It's just going to run better on some devices than others. Same thing with multimedia. With all these new resolutions, it's computationally hard to get media onto the display, to decode video at VGA resolutions and put it on the display at 30 frames a second. It's a lot of data to move. It's a lot of data to think about moving. It's a lot of data to decompress. It's a hard problem. So we have a pluggable codec architecture so that people can optimize it differently on their platforms. We talked about there are different ways to hook up memory. There are different ways to hook up displays. There isn't one solution that's right for all these architectures. And these architectures each have their advantages. But it's important to write software to make the most use of what the hardware has to offer. So the pluggable codec architecture allows people to write targeted solutions to use any hardware acceleration that's available, any special attributes of the bus, whatever has to be done, they can do it now. Currently, they have to replace the whole codec. Going out into the future, people will be able to use just piecemeal, what parts. So color conversion is a step required in, color space conversion is a step required in any media decode. MPEG, WMV, doesn't matter. But it takes time. It's a pretty substantial CPU overhead to have to do that. And so instead of someone having to rewrite the entire Windows Media Codec just because they have color space conversion hardware, we let them use all of the decode, but then use their own color space conversion part in hardware. And with all of this, you're going to just see great frame rates on devices. We're targeting full frame rate video playback at device native resolutions. On a VGA device, you should be able to see 30 frames per second video playback in the future. On record, 15 to 30 frames per second for devices with hardware acceleration. Encoding video is extremely difficult. So on a device without hardware acceleration, I wouldn't expect that kind of frame rate at VGA, but it'll get there. And now you've heard all about the great software, all about the new hardware you can run it on. So set to go out and write new applications to run on everything. And before you do that, I think there's still time for those of you not running straight to the airport to, if you haven't yet, check out the Windows Mobile Information Center, get the resource kit. A lot of us, the developers, we're all still hanging around outside in the hallway. Feel free to come find any of us, ask more questions, and fill in your evaluation form. It's important for us to know how we're doing so that we can make it better for you in the future. And besides, you can still win a phone, 1 per time slot given away. So please. With that, open up for questions. Anything you want. Yes. Mm-hmm. So the question was about camera interface. Actually, I think 2 questions. One is about camera interfaces. Currently it's SD and compact flash, and where that's going in the future. And the second question is just imply where those interfaces are going. I think as devices get smaller, we'll see less and less compact flash solutions. When I was talking about a camera interface in the presentation, I was referring more to devices with built-in cameras. More and more prevalent. There's a few types of standard buses that are used in hardware to connect that. But with all the different options for acceleration, it needs to be abstracted for software so people can do optimized solutions. Now, expansion in general, devices are getting smaller. Expansion is going to get smaller. SDIO is replacing compact flash for a lot of things. You can get an SDIO wireless LAN card. People have demonstrated SDIO GPS cards, Bluetooth. It's an expansion form factor that has basically just helped the peripherals keep up with the pace of integration for the hardware that goes inside them. And going forward, now there's mini SD and half-size MMC, more form factors coming. It's something that's just going to get smaller and smaller. Yes. So going from MMC, for example, to SD, quadrupled the bus width and slightly higher clock rate. There's high-speed SD, which is about 2.5 times faster, I think, than current SD. More options coming.
What about resolutions higher than VGA? Windows Mobile unique apps experience?
So we look at just about everything. And right now, resolutions higher than VGA, VGA screens are cutting edge of technology, what's available right now for these kind of size devices. And that's where we're at. You know, as new resolutions become available in hardware, we certainly look at it and evaluate it going forward. So don't have specific plans we can talk about for resolutions past VGA. Anything else? So, no touchscreen for smartphone. No. No. No touchscreen for smartphone. No. Because there's Pocket PC. It is a different platform, and it's an important distinction to have. You know, there are times that you want a touchscreen and the Pocket PC UI. Smartphone, we did all this work to make the UI usable with one hand and a 5-way navigation. And to go and put a touchscreen on there, it doesn't really have that value to the user. It starts to diminish the value of the smartphone platform. Use Pocket PC. Well, now we have smaller screens available for Pocket PC. Now that's, again, you know, the hardware innovation trying to expand the range of screen sizes you can have, like that flip-top smartphone-looking Pocket PC. That's a Pocket PC. It has a touchscreen. Everything you want on a touchscreen, it's the size of a phone that fits in your pocket. I don't have one here that I can hand you, but it's really a compelling phone form factor. So anything you saw up here are internal concept and prototypes. Again, we don't do shipping hardware. And that's up to our partners, and I really can't comment on any specific partner devices. Mm-hmm. So Pocket PC already is a rich platform for media functionality. You can put a hard drive in it today. You can do great video playback. Portable Media Center is part of a different group at Microsoft, and it's a much more targeted, closed box type of platform. So, I don't know. Mm-hmm. Yeah, no, we really work to make Pocket PC a great media playback device. But Pocket PC has to be designed to do other things too. For Portable Media Center, because the device is specifically targeted for media playback, the user experience can be totally optimized around it. All those trade-offs that have to be made, they can go and they can focus on just, it's all about watching video and playing back music instead of having to look at, well, it has to be usable as a phone and other things. So that's really the core difference there. Sure. From the Microsoft standpoint, you know, we're radio agnostic. We abstract all of that to the software. You can run GSM, CDMA, GPRS, future radios, no problem. It's, you know, I'm not sure exactly what you're asking from. Oh, okay. So that's what we do. So we have what's called the radio interface layer. Is a piece of software that's a layer so that when you're writing applications, it doesn't matter whether you're on GSM or CDMA. It's just not a problem. Or future radios too, Edge, UMTS, whatever's coming down the line, it'll be completely abstracted that way. So Wi-Fi and Bluetooth work a little bit differently. Wi-Fi is a network card, effectively, and so that's a different interface than making a phone call. And Bluetooth has, you know, their Bluetooth profiles that get used, and so there's another software mechanism for the Bluetooth stack to work through. The question is infrared a requirement for Pocket PCs and smartphones? It has been, and I'm not sure whether it is in the future. And yeah, and that's an example of just an area where we're always, in building these devices and using these devices ourselves, looking at how to specify them in the future, what's going to be the best for the user. But for now, infrared, it's really cheap and easy from a hardware standpoint. It just works. There are a lot of good things about it. One back there. So in general, as more functionality comes in, there's need for more code storage. But one of the great things is that with user storage and flash, you can really just keep the RAM at a constant level. And so look at going for, like just general trend going forward, more flash, and possibly even less RAM. So there are a few ways from a hardware side to look at that. So the question is about how do you do a voice over IP call with 802.11? The answer is it's the same way you do a voice over IP call with Ethernet, GPRS, anything else. From a hardware standpoint, the device has an audio input path. Then the processor would packetize the audio and send it out over the network, receive audio, decompress it, whatever it has to do, play it through the audio output path. It's not like a GSM phone call where there's a phone processor just handling a voice call. Well, not necessarily shut down. When you say, do you shut down the GSM, there's no reason that you have to shut down the GSM because you have a voice over IP call from a technical standpoint. And you might still want to be registered on the network in case someone calls you. There isn't really the infrastructure to have seamless handover everywhere you go. In the back? The question is about, with solar power, new solutions, are we looking at other ways to charge the battery? This is an area that OEMs have pretty much carte blanche to go do whatever solution they want. They want methane fuel cells, they can have methane fuel cells. We have requirements for battery life, and if they can meet those, great. If they can still meet the size goals, even better. As far as solar charging specifically, we haven't built anything around it ourselves, but there's nothing in there that keep it from being done. Batteries are a funny thing. All of this technology advances so quickly, but batteries are still kind of incremental. So looking forward, as the devices get faster and faster, the processor speed is doubling very quickly, new media accelerations, everything else. Battery life, it's a struggle to keep up. The question is there, just try to distill it here, is there a conflict between our desire to standardize and OEM's abilities to differentiate? Talking specifically about one partner who had to extend the OS in some ways for their platforms. We work closely with all of our OEMs to help them build new devices and extend in ways that we hadn't necessarily thought of. And what we're trying to do is enable them to differentiate. We want this huge spectrum of devices out there. There's plenty of differentiation options available within the new specifications. As far as different form factors, there's some core requirements of screen size and functionality. After that, go for it, whatever the market wants. So the question is, what's the likelihood if additional screen resolutions of CE 5.0? So Windows CE and smartphone and Pocket PC, two different things. Smartphone and Pocket PC have specific screen resolution supported. Windows CE, you can do anything you want, no problem. It's been supported for forever. It's the video driver, anything you want. So same answer as just a moment ago. These are the resolutions that we're supporting right now, and we continue to evaluate all of our specifications as technology changes and the market changes. I'm sorry, could you speak up? I think that the serial port will stay on Pocket PCs. Or will it go more to USB? I think going forward, you see much more USB. And there's serial ports on so few new PCs and everything has to support USB. So going forward, you'll see just a lot more USB and less serial in the device space too. When will we see USB 2? Sometime in the future. Sometime in the future. I'd say just from a hardware standpoint, it's a tough thing to put into devices right now, and that none of the core so when these devices are built, there's one main CPU applications processor that has tons of integrated peripherals, USB being one of them. They don't have USB 2 on them now. So to add USB 2 to a device, it's an extra chip, it's expensive, it's a lot of power. And as the devices go forward with, start seeing more video devices and things like that, more applications that have a need for the high-speed bandwidth, we'll start seeing higher speed USB on the devices. USB host. So it is possible for OEMs to do devices with host functionality. But if you just look at what our software does, the question is, what do you want to be a USB host to? Someone could implement host functionality to have a keyboard plug in. And it's an area that's left up to the OEM. My question is, will OEMs be able to support 3D acceleration before Windows Mobile Next Generation comes out? Now, it's a flexible platform. People can build whatever they want to on top of it right now. It's just that in the future, we're just we're making that experience easier for them. So it's definitely possible today. Any plans for multi-processors on these devices? Well, in some ways, they're already there. This phone actually has 3 processors, 2 that run the radio and one that runs Windows CE. It's all on one chip. As far as multiple processors running Windows CE, there's a lot of overhead in doing multi-proc solutions and not necessarily a lot of benefit in these devices. It's definitely something that we've looked at and understand the issues there. Anything else? Well, thank you all for coming. If you have any other questions, come find me.